Right, this video is all going to be about vertical motion, and we're going to look at an example of a problem and how we might use some information we know about vertical motion to solve this problem. So you can see, well, let's just go through a few basic ideas for a start. So the first one being is that when we have vertical motion, the motion only has one force acting on it. So that there's only one force that causes the unbalanced force, and this force is the force due to gravity. Now the force due to gravity acts directly downwards towards the perpendicular to the surface of the earth, and using our frame of reference we say that anything going down is negative and anything going up is positive. So our acceleration is going to be negative 9.8 meters per second per second. Now, the next thing that we need to know here is that, we've talked about gravity being the only force acting on object. At the top here, so right at the top, when I let something go, or even if you throw a ball up into the air and it reaches its highest position and then falls back down, when the ball or the object is its highest possible position, then its velocity equals 0. So at the highest possible position, VI equals 0. And we can, so in this case here, if I have a ball, if we have a look, there's a ball that falls from Eiffel Tower, we could say that the ball had an acceleration of negative 9.8 meters per second squared, and we can say it started at its initial velocity, its VI, must have been 0. This is before anybody asks us any particular questions about it. We can state that at the beginning, at initial, the velocity is 0, and we can say anywhere along its path or its journey, the acceleration was 9.8. So here's our specific question here that we're going to pull apart and just see how this works. So the question is, a ball is dropped from the top of the Eiffel Tower, this being the Eiffel Tower, and the ball was up here. It takes 8.13 seconds to fall. What will be the height, or what is the height of the Eiffel Tower? Okay, so let's have a look at this. Well, we can see there's a piece of information here, so we're going to underline this. And we can see that this is the time. So the time for this problem equals 8.13 seconds. It's an important quantity that we know. Now remember, we already know that because we dropped it from the start, that VI equals 0. And we know that especially from this question that it says it's been dropped. So when we say it's been dropped, we are then inferring that it started from 0 velocity. And we know as it goes through its journey, as it falls through the air, it is accelerating at negative 9.8 meters per second per second. That is, it's accelerating at 9.8 meters per second downwards. So I now have 3 quantities that I know. And then I look at what is it they want us to find out. They want us to find out the height. That we know height, the symbol we use for height is D. Sometimes you'll see that somebody writes an H in, but D is the symbol we're going to use when we choose our equation. So what we do is we look at the equations to do with kinematics, and we choose one that has D in it, that I can make D the subject of, and it has variables that include these 3 and nothing else. So when I do that, here's what I get. I find this equation here, and this seems to fit what we want. Let's have a look at it, because we can actually simplify this equation for a start. It's really quite simple. So it says, if we look at this first expression, VI times T, but look over here, the VI equals 0. Now we know from our mathematics that if we multiply 0, which is VI equals 0, by anything else, it becomes 0. And when we add 0 to anything else, it's just what it initially was. So in essence, if I ever have a term that is multiplied by 0 or has a 0 in it, I can remove it from my equation. So I removed that from the equation, and then I substituted my two values, my acceleration and my time, just like this. So I've put in my acceleration as negative 9.8, and my time is squared. So 8.13 squared times negative 9.8 times a half. And we get the answer, negative 324. Now let's go back and look at our initial data. We had the time of 8.13, which is 3 significant figures. We had acceleration at 9.8, which is 2 significant figures. Now velocity is 0, but we can think of that as an infinite amount of significant figures, so that's irrelevant. Our smallest number of significant figures is 2 from the value of acceleration. So we need to round this 4 down to 320. And I don't need to supply the negative because they asked me what height is the Eiffel Tower. That is, what is the distance between here and here. They didn't ask, do we go down or up? They just want to know the total magnitude of the distance. So I've just put 320. So this is a question on vertical motion. Just recapping, look, we know with any vertical motion, the acceleration is always equal negative 9.8. We know that gravity is the only force accelerating the object, and we know at the highest point our velocity equals 0. The last thing that we always assume as well is that there's no friction when it falls, so we only ever have to worry about the acceleration due to gravity. Okay, thanks for listening to this video. Keep a lookout for the rest on this topic.